Welcome to the Streaming Summit 2025. Today we will share a topic about how Ursa eliminates interroad traffic. I'm Penghui, the director of streaming. I'm leading the platform team to build Apache Pulsar and Ursa now. And before joining StreamNative, I'm a software engineer at Jumping.com. I was leading the Pulsar adoption at 2018, which is the first Apache Pulsar adoption in China. I'm also Apache Pulsar committer and PMC member. Yisheng, do you want to introduce yourself?
Hello everyone, I'm Yisheng, a staff software engineer in StreamNative. I mainly focus on cloud integration and infrastructure automation to develop event streaming platform in the cloud. Thank you.
Yeah. Before we go to the details of interroad traffic and to eliminate the interroad traffic, I will give you a brief introduction of Ursa. What is Ursa? Yeah, Ursa is built for multi-protocol. It can support both Pulsar API, Kafka API, as well as QTT protocol. So you can use both streaming and messaging workloads or one cluster. Yeah, Pulsar API can provide more flexible queue features, but Kafka API is more like a defector from the data streaming area. And Ursa is also optimized for real workloads. You can use cost optimized tenant or latency optimized tenant or one cluster finally. Now we only support the cost optimized tenant, but we are working on the latency optimized tenant for now. So finally, you will use the same architecture for both cost optimized use case and latency optimized use case. And the last big difference from Ursa is Lakehouse native engine. It will connect the data from either Kafka topic or Pulsar topic to Lakehouse directly. You don't need to run any connector. It will happen automatically, and there is no interroad traffic when ingestion the streaming data to Lakehouse. So it can provide you a unified like a streaming and table like in one platform. And it's today we will talk about the interroad traffic traffic cost from the traditional either Kafka or Pulsar. We will start from layer by layer. It's like a client to the broker side and the broker internal replication. And if you want to connect the data from the topic to a lakehouse, you need to like manage the connector. It might also cause internal traffic. It's avoidable, but you need to do more configuration to avoid the internal traffic. So now I will move to Yisheng to explain more details about client to broker interroad traffic.
Thank you, Penghui. Let's dive deeper into the interzone traffic issue in the original Apache Pulsar or Kafka architecture. First, we need to identify the components involved in the message Pulsar. On the client side, we only need to focus on consumers and producers. The key requirement is that these clients must be deployed in the same cloud provider and region as the server. Otherwise, all traffic will be classified as inter-region or internet traffic. In server side, we mainly have the following components, like broker receives message from producers write data to the storage layer, and dispatches message to the consumers. And next is still ingress gateway. It serves as an SNI proxy in StreamNative Cloud, replacing the POSA proxy or something like that. Since each partition has a single leader, we need a method that allows clients to communicate with specific brokers. It routes external traffic to various brokers while offering advanced network exposure capabilities, security, and observability. Finally, the load balancer. If we need to expose the service to the network out of Kubernetes, we will involve an internal or external load balancer as a bridge. As shown in the diagram on the right, interzone traffic can occur between clients and the load balancer and Eastern Ingress Gateway and the broker with a storage layer. Now let's start from client to load balancer. As we all know, each topic has an owner broker, and every broker has its own endpoint. Like this in this diagram, the broker 0 has an endpoint pb0.broker.com, and the broker 1 has a pb1.broker.com. So when clients consume or produce message on one broker, they will talk to the owner broker directly by the specific endpoint. So the interzone traffic would inevitably occur if clients and the owner broker are located in different zones. But nevertheless, let's assume there is a topic owner available in each zone. So clients only need to tell the brokers which zone they belong to. Then brokers can theoretically return an owner broker endpoint for that zone. In this way, client-side interzone traffic can be eliminated. Like in this diagram, we can see the client needed to provide not only the topic information, like the topic 3, and also tell the server side, this we are accessing from the zone A, so the broker will just return the address of the pb0.broker.com, since it's also an owner of topic 3 and it's located in zone A. So go to next layer, the load balancer to Istio gateway, and also the Istio gateway to broker. Since the load balancer itself is a regional workload in most cloud providers, so we need to deploy a dedicated load balancer for each zone to completely avoid interzone traffic. And there are backends Eastern Ingress Gateway in the corresponding zone. With this infra setup, what we needed to do for broker is defining rules to expose zone A broker with zone A gateway and point DS of zone A broker endpoint to the zone A load balancer. This configuration may too complicated for the Helm chart deployment solution, since they cannot make the change dynamically. But we can easily implement this by the StreamNative operator. Furthermore, is it possible to achieve this goal with only one load balancer, as it also incur costs? We found it's possible in AWS. AWS Network Load Balancer provides additional zone endpoints, allowing us to point the DNS of broker endpoint to the zoner endpoint. This way, we can have the same effect as the multiple zonal load balancer solution. Let's see the diagram. For the zone-aware load balancer, yeah, like we can just point the zone A broker to the zone load balancer endpoint. And so we don't need to deploy multiple load balancer in each zone. For the rest part, in zone traffic between brokers and the underlay components, I will pass this to my colleague Penghui.
Thank you, Yisheng. For the next layer, it's the internal traffic from broker to broker. Yeah, as you know, like for both Ursa and Apache Pulsar and Apache Kafka, for each partition, there is a leader broker. It's for for the data consistency and ordering. After you publish the data to a topic, then no matter how many times the consumer try to read from this topic of partition, you will also get a same ordering. And it's like if you have the same leader, it's most simplified the design. It's everything can control from local memory or some like if you have any state need to like coordinate. And so from broker to broker, there are data replication Kafka. It's for Pulsar, it's different but similar for Pulsar since the data replication is not happen from bookie to bookie. Actually, broker will write multiple replicas to broker directly. So no matter or a broker write to bookie or a broker to broker replication, it designed for to get fault tolerance. You are able to recover the data like yeah, after one broker is not available or something, and it's also designed for a high available. One broker is not available and another broker can take over a service maybe in just like yeah seconds or something. And it's also designed for durability. You have multiple copies from different available zones. Yeah, but so this is why we need either both leader broker and this replication. In Ursa, it's actually we are following the diskless architecture. There is no local disk or broker and we removed like a bookie architecture. There is no bookies or Ursa. And so each broker will write to cloud storage directly. Like you will get a higher write latency, yeah, but you will not be sorry. It's the cloud storage will not charge the internal traffic fees. It actually replicated data across multiple available zones. You will still have three copies, but there is no internal traffic fees. So the Ursa will not have a single leader for each partition. The client side can connect to any broker from the single zone. So each broker can support write the data read from from the cluster of our topic. And we also have our OCI, which is the scalable metadata service, and this is also the bedrock of Ursa engine. So when like we use Ursa to generate the data offset and message indexes, it's just for different concept from like Pulsar and Kafka. You need to have a centralized place to generate the offset. Otherwise, you will get duplicated offset or it's from different brokers, right? So with the data offset generation, you will also always get increased offset for a topic. And we also use the Oxia as the message index. Data is written to the blob storage, but the index is written to Oxia. So from the consumer side, it can get the message metadata view from the Oxia cluster. It doesn't need to read the data from S3 to know okay, how many messages the partition have or something. And Oxia can also provide a consistent order no matter how many times you read from the partition. So actually, it's from broker to Oxia. It still has internal traffic. We leaderless means there is no single leader for partition, but Oxia still has leader for for each third. But it seems like you have both post broker and a keeper or a Kafka with zookeeper. Yeah, zookeeper has leader. This part is not changed. We just removed the topic leader from broker. So there is internal traffic from broker to Oxia, but it's like almost zero. It's if your traffic's you have high traffic with high throughput, okay, it's the map data is maybe just a few kilobytes per second or something. And the last part is the Ursa is designed for Lakehouse native. So if you want to connect the streaming data from topic to Lakehouse table, you need to deploy connectors, lake connectors. With the Lakehouse connector, you have a real-time data ingestion to Lakehouse, and it's scalable. You can deploy multiple connectors to handle a high throughput streaming data. And it also simplified the data ingestion pipelines. You don't need to write any your customize the code to use consumer to read data from broker and write to lakehouse. But actually, this part is, I think most of the connectors, I exposed the option to configure the feature, allow a Kafka consumer to fetch the data from the follower. But actually, you must need to set the configuration, otherwise it will just go to the leader by default, I think. But for POSA, POSA there is no feature fetch from follower or something. It can only read from the single leader, since the POSA state replication is stored in broker. It's not stored in bookkeeper, not broker. So this is why like connectors might also introduce internal traffic. Ursa is resolve the issue. It's in a different way. In Ursa, you don't need to deploy any connectors for ingesting data from topic to lakehouse table. Instead, we have the data compaction service. The data compaction service is just compacting the streaming data. Actually, it's a while log. It's since we will write the data from multiple topics to a S3 object. In this way, we can reduce the cloud storage API cost to but the difference is the compaction service will write as the packet file or table format. Like so, after the compaction service, read the while log and try to move the data to based on topics, and then you should able to when you do the catch up read by post our consumer, you will read the compacted data. And the compacted data is also like a table format data. So you are also able to query data by table API. Yeah, so that is a major difference. And the compaction service is just talk to cloud storage and Oxia. It will not talk to a broker, and it also like running out of the broker. The trade-off is we want to provide the guaranteed quality of service. We want to avoid any resource contention from compaction to broker. And so there is no cross-zone traffic fees from the compaction service. So this is how Ursa eliminating all the internal traffics from the top to bottom. This is all the topics we shared today. Thank you.
Awesome. Thanks everyone for being a part of this session. Let me see if there are any questions. Meanwhile, I can, have our speakers also can be here. One moment. Feel free to put your questions if there are any in the Q&A panel. I don't see any questions so far. Hope you guys enjoyed this session. We'll stick around a little more to give you an opportunity to put the question there. So one of the presenters, Yisheng, is here. He'll be able to take any questions if you have. Okay, I think there's one question here.
Okay, yeah, let me check the question. So the question is, do we have any estimation about the saving traffic? Yeah, I don't remember the detailed data, but we use a VPC flow log to calculate how many internal traffic we save. I think we can say we saved almost all the internal traffic. Just some internal traffic will be generated by the like topic lookup and the metadata write and read. So we can say almost no internal traffic will be generated in the Ursa engine solution.
Okay, that's great. I'll mark the first one as answered. There's another one here from Hubert.
Yeah, I think it's also maybe related to the metadata. Yeah, the metadata will have cross-zone fee, and since we need the high availability and for the fault tolerancy, but this the data volume is very limited compared to the messaging sizing and all the streaming data. It may, if you have like many like I think the gigabyte level is a very high level for the metadata internal traffic, and it only cost little bucks a month. So we can ignore that in this case.
Okay, perfect. Let me see. I don't see any other questions. Yeah. Yeah, well, other questions come up. This is going to be recorded anyways and shared. Definitely, if you have more questions as a follow-on, please reach out to us. Actually, no, I don't hear Penghui. Penghui, you'll have to actually come to the main stage. You'll have to click on the button called Enter the Webinar on the bottom right-hand side corner, and that should let you actually come to the webinar. There you go. We see you now.
How about for now?
Yeah, we can see you and hear you now.
Okay, sorry. Yeah, I mean, I think I can explain more about the details about the internal traffic from to the metadata service. It's first, we did not create like one index for one message. Actually, we will create for a batch of messages. Like for example, by default, like we only flash the data to S3 like for every 250 megabytes. So sorry, milliseconds. So like for each topic, we will only have like one index in 250 milliseconds. Yeah, so it, it's not like a linear increase with your like how many messages are published in a second or something. Yeah. So there will be we tested like with 5 gigabyte per second. Actually, the metadata sorry, the metadata traffic is lower than like 2 megabyte per second. Yeah, but the actual traffic is 5 gigabyte per second.
Okay, that's great. Let me see. I don't see any other questions at this point. Okay. If there are no other questions, we can sort of end the session. You'll have a few minutes of break before the next one starts, at least on this track for the deep dive. And just give you 10 seconds to decide if there's any more questions. Cool, perfect. So thank you again, everyone. Thank you, Yisheng and Penghui for the session. And the next one starts in a few minutes, I guess. So we'll talk soon. Thank you.
Yeah, thank you.
Thank you.